Okay, guys, before we get started, I want to ask you, at what rate are you making money? And at what rate are you spending money? And depending on what rates you tell me, is your amount of money increasing or decreasing? So let's do a real life example. For example, um, I make $10 per hour. Okay. If I make $10 per hour, okay, and I spend, so this is how much I make, and I spend $3 per hour, is my amount of money increasing or decreasing? It's increasing, right? Why? How do you know? Because 10 minus 3, this rate that I'm making money, minus the rate that I'm spending money, is actually a positive number. So therefore, my amount of money is increasing. What if I have $3,000 in the bank? Would my money still be increasing? Yeah, whether my money is increasing or decreasing is not dependent on how much money I have in the bank. Okay. What if I am making $10 per hour, but I'm spending $12 per hour? Okay. Then is my amount of money increasing or decreasing? Decreasing, right? Why? Because the amount in minus, or the rate in minus the rate out is negative. And when the rate in minus rate out is negative, then that means the amount of money is decreasing. What if I have $3,000 in the bank? Does that matter? Is my money, the amount of money, still decreasing? Yeah, it doesn't matter how much money you have in the bank, okay? Um, if you if the rate in is more than the rate out, then you're going to be increase, your amount of money is increasing. If the rate in is less than the rate out, then your amount of money will be decreasing. And it doesn't matter how much you have in the bank. All right, so knowing all that, let's do our first problem. When a grocery store opens, it has 50 pounds of bananas on display at a table. Customers remove bananas at this rate here, at this rate of F. So what I have is on a table, okay, I have 50 bananas. So 50 actually pounds of bananas. And then bananas are being removed at a rate of FT. And the units for FT is pounds per hour. Starting at time, let's see, T is the number of hours after the store opens, so it's when time is greater than 0. After the store has been open for 3 hours, employees start adding bananas to this display. So there's a rate in, and the rate that we're adding bananas is GT, and that is also in pounds per hour. However, this doesn't happen though until T is greater than 3. Okay, so G doesn't start until T is greater than 3. All right, so knowing all of that, we make this diagram. This diagram is very important to make. And what you can glean from this diagram is, first of all, notice that GT and FT does not have the same units as 50 pounds of bananas. G and F are rates, whereas 50 is an amount. So you can never add 50 with F and G. Second, realize that if you integrate a rate, you get an amount of change. So if I integrate GT dt, what I get is pounds per hour times hour, okay? And that'll give me pounds. So if I integrate this rate, I'll get the amount of change of pounds of bananas. I'll get pounds of bananas going in. And if I integrate the rate ft, I'll get pounds of bananas leaving. Okay, so that's interesting. That's how I can convert this, in a sense, to pounds. And then the other thing to see is that when you integrate, what happens is you lose one of these divided by hours. So if I started with pounds per hour, like FT, if I integrate it, then I end up multiplying it by hour. So the answer is pounds. Okay, and that's similar to what we see when we have position, velocity, and acceleration, right? Because position is in meters. If we take the derivative, we get meters per second. And if we take the derivative of that, we get meters per second per second. And if we kept on going, we'd get meters per second per second per second, right? Third. Okay, that's the derivative. But when you do the antiderivative, you lose one of these seconds, one of these per time things on the bottom. So if you take the antiderivative with respect to t of with respect to time of ms of 3, you'll get ms squared. Okay, and so likewise, when we integrate a rate, when we have pounds per hour, we lose this hour here on the bottom. Okay. All right, so what we're going to first find out is how many pounds of bananas are removed during the first 2 hours the store is open. Well, which rate talks about the removal of bananas? This rate right here, the f of t. So if we want to remove the number of, find out how many bananas are removed, we would integrate the rate of removal. You want from time 0 to 2, okay, and figure out what this answer is. So what we're going to do, call this g of t y1, so that's the rate in, and call this f of t y2. So I'm going to go ahead and store this in my calculator. So gt here is going to be y1, and then ft up here will be y2. So notice I put my y2 for the f, and that even though the f was given first, I'll call it y2. So I'm going to put that into my calculator. Make sure your calculator is in radian mode. And so y1 is going to be 3 plus 2.4 ln of x squared plus 2t. I know there are t's there, but my calculator just thinks it's some variable, so I can use x's. Right here, y2 is going to be 10 plus 0.8 times t. I think I could just put the x there, times sine. I like the multiplication symbol, so I'll leave it, but I don't think we have to have it. x3, x to the third divided by 100. Okay, I'm done with y2. All right, so I've got y2 and y1 in, and this problem here, letter A, says I want to integrate, so I'm going to go to second quit to my home screen, do a math 9 to integrate, go from 0 to 2. Right there, the f of t now is y2, so you can go vars, y vars, 1 for function, and 2 to choose y2. Make sure you close up your integral, put it next there, and pray, hit enter, and there's my answer. So 20.051. I need 3 decimal places. I can round or I can truncate correctly, and according to this problem, it's the same whether you round or truncate correctly. You don't need to put units. Actually, don't put units unless you have to. I don't need to put units here because it's not requested, but if I did, it would be pounds. All right, so the next question is, if this is f of t, what would be f prime of 7? Now, without thinking much, I know I have a calculator, so all you want to do is just do a math 8, put in f, and get the derivative of f and plug in 7. Okay, so remember, I made my GTY1 and my FTY2. So I'm going to go to my calculator, and I'm going to do a math 8, okay, with respect to t, but instead of t, I'll just use x, because I used x's up here for y2. So I want to put y2 here. You can hit alpha trace and choose y2. You can also do vars, y vars function y2. And this one I'll put in the number 7. So what I'm doing is I'm taking the derivative of y2 and I'm plugging in 7 all at one time. And so what I get is negative 8.11. So let me record this here. Negative 8.119 or negative 8.120 if I round correctly. And The next question it asks is, what are the units for f prime? All right, well, the units for f are right here, right? The units for f are pounds per hour. So if I take the derivative of that, remember that would just add another times value in the denominator. So it'd be pounds per hour per hour. But really what that is pounds per hour squared. Pounds per hour squared on the bottom here. It'd be pounds per hour, basically per hour, but then this is really hour over 1. So dividing fractions easy as pie, flip the second and multiply. So what you get is pounds per hour squared. Okay, and we knew that from, from meters per second to meters per second squared when we take the derivative. The next question is how do you explain this, what this f prime of 7 means? And what you need to do is you need to memorize this phrase. Okay, you need all these things in the blank, and you need you need numbers with units. So first you would say f prime of 7 means at t equals 7 what? 7, this is a time, so at t equals 7 hours, okay, if you want f prime, you would put f in here. And what is f? Well, f, we know, says up here, is the customers remove, it's the rate at which customers remove bananas, right? So it's the rate at which bananas are removed. So right here, you can write the rate at which bananas are removed. And there's some keywords here. You don't have to have perfect English. You could say rate bananas are removed. Perfect. Fine. Okay. You're looking for some keywords. So at time equals 7 hours, the rate at which bananas are removed is what? Is it increasing or decreasing? Well, this number, this rate is negative. So you would say decreasing at a rate of, and then put this number, like if you say decreasing, then you say that this is 8.120, okay? And you need the units. The units for f prime is pounds per hour squared, okay? Another way you could do it, although AP is moving away from this way, but you could also just memorize that this is changing at a rate of, you could say negative 8.120 pounds per hour squared. Okay, and in the past, the red has always been acceptable. AP is moving towards the green, but it's not a sure thing that you you have to say it in the green way. But we see some readers are pushing towards that, so just beware. Right now, I think both are correct. For sure, if you say decreasing, do not say decreasing at negative 0.8120, because now you've got a negative and you're really saying increasing. Okay? All right, let's go to the next question. Is the number of pounds of banana on the display table increasing or decreasing at time t equals 5? And give a reason for your answer. We talked about this earlier. Is your money increasing or decreasing depending on your rate in and rate out? But let me use calculus to show how to do this, and then I'll show you that it's really the same thing as what we did with our money. All right, we know that A of t is, we didn't get this from the beginning. Let me go back. Down here, whenever you want to find the amount, actually I can just copy this over here. If we ever want the amount, right here, the amount of bananas or whatever the problem says, if we want the number, okay, it's always equal to, you integrate this rate to get the amount, so it's the amount in plus the amount existing at time 0 minus the amount going out. But to get these amounts, to get the amount going out, you'll integrate the rate going out. To get the amount going in, you'd integrate the rate going in. So basically, the formula for amount of bananas is going to be what you start with, okay, plus the amount going in, but that means you integrate the rate to get it to go in, minus the amount going out. And to get the amount of going out, it's integral of the rate out, okay? And then you put in these dt, time goes from 0 to t, here, and time goes from 0 to t. Okay, now there's something wrong with this problem. Do you see what's wrong with this problem? There's something technically wrong. I put something wrong in here. What's wrong is GT doesn't start until time is 3. Okay, so instead of 0 down here, okay, instead of 0, this should go from 3 to t. All right, so this is how we figure out the number of bananas after time 3. Okay, after time 3, this is the formula for the number of bananas. Okay, and so we're looking at time 5, so we're okay with this formula. All right, and we want to know, okay, if this is a formula for amount of bananas, and it's based on this right here, which is on your notes, this formula here. How do we figure out if the amount of bananas is increasing or decreasing at time 5? Well, you know from calculus that when a prime is positive, a is increasing. And when a prime is negative, a is decreasing. And we have a formula for a, so we just need to know if a prime at time 5 is positive or negative. So what you do is first you take the derivative. The derivative of 50 is 0. The derivative of the antiderivative of gt, oh, the derivative of the antiderivative, isn't that the derivative of the first times, plug the t in everywhere there's a t, minus the derivative of the second limit times, plug that in. And do you see that this is really just gt, according to the second fundamental theorem of calculus? And remember, the derivative of 50 is 0. So this is really just gt. And if I do the same over here, the derivative of the first times plug it in, minus the derivative of the second, derivative of 0 times plug that in, I'll also get ft. And this minus sign here is just carried down here. Okay? So what did we just get here? The derivative of a is expressed by gt minus ft. So if a prime is positive, then a is increasing. Well, let me see. A prime at 5 is going to be g at 5 minus f at 5. Okay? And so do you see that this is rate in minus rate out? Okay? And that's what we talked about before. If my money going in is more than, if the rate of money going in is more than the rate of money going out, this will be positive and my money will be increasing. If the rate going in is less than the rate going out, then my amount of money is decreasing. Okay, so this number is negative. All right, so it's really the same thing that we talked about before. So what I need to do is find what G5 is, find what F5 is. I remember that I made this one Y2 and this one Y1. Okay, so this will be Y1 at 5 minus Y2 at 5. Put that into your calculator. So I'm going to put Y1, so that's alpha trace, choose Y1, open your parentheses, put in 5, minus Y2, so that's alpha trace, but I'm going to choose Y2 now, open my parentheses, put in 5, close your parentheses, press enter, and what I get is negative 2.263, okay? Negative 2.263, what? Well, these are both rates, so if I wanted to know what this is, this would be pounds per hour. Okay, now you don't need to put the units, so don't put the units, but I wanted to show you that if they asked, that would be pounds per hour. Since this is negative, you'd say the number of pounds of bananas is decreasing. And the reason would be because A prime at 5 is negative. You could also say because A prime of 5 is, you could also say because G5 minus F5 is less than 0. Same thing. How many total pounds of banana are on the display table at time 8? Okay, let's look at this question. I know the formula for the total pounds of bananas. It's AT is equal to 50 plus the integral of 3 T GT dt minus 0 to t ft dt. And if I make this time here 8, right here, then I'm also going to make this time here 8 and this time here 8. Do not change these times here to 8. These are the t's that need to be integrated before you plug in 8. All right, so leave all the other t's alone. So I know A8 will be equal to 50 plus 3 to 8 gt dt minus 0 to 8 ft dt. So we have a calculator. All right, just get your calculator out and put in 50 plus math 9. We're going to go from 3 to 8. Okay, remember our g was y1, so I'm going to pull my y1, x minus math 9, go from 0 to 8. I'm going to pull my y2, and close up my integral, press enter, and there's my answer, 23.347. Okay, if they asked for units, this would be pounds of bananas, but they don't ask for units, so I can leave it the way it is. All right, if you look at the scoring guidelines, you can see that every free response question gets 9 points. And if I got this integral correct, if I just set it up correctly, I would get 1 point. I think this problem is simple enough that I'd miss the dt, it wouldn't be a big deal. But it's good to have good notation. And then if I got this number right, then that would be the answer. All right, you only need 3 decimal places. All right, for the second part, getting the number right is worth 1 point, and then writing this meaning out gives you the last point. Okay, and then for the third question, if you consider G5 and F5, okay, if you consider both of those in your solution, then you get 1 point. And then if you got the reason right, then you got the second point. All right, and then the last part, there are 2 integrals. There are 2 points for the integrals. So if you got this right here, that was 2 points. And then the answer is worth 1 point. Let's go to your homework. Look at number 2. There's tide. It removes sand from a beach. And the rate that sand is being removed is expressed by RT. You're also going to add sand to a beach using a pump. And the rate that sand is being pumped in is S. So let's take a look at this beach. Okay, the rate being removed, the rate of sand being removed is RT. Okay, and it does tell us cubic yards per hour. So this is cubic yards per hour. And then the rate of sand being pumped in is ST, and that's also cubic yards per hour. So I'm going to call this Y2 up here because that's rate going out. I'm going to call this Y1 down here. The amount of sand in the beach right now is 2,500 cubic yards. Notice the blue is cubic yards. The red are our rates, so I cannot add the blue with the red. This right here is the amount of sand. But if I integrate the rate, I could get an amount going in, and if I integrate this rate, I would get the amount going out. And everything is between times 0 and 6, so I don't have to worry about these times starting at different limits. All right, first question. How much sand will the tide remove from the beach during the 6-hour period? So the tide removal is expressed by this RT. So if you integrate a rate, okay, this is with respect to time, so from time 0 to 6, you're going to get an amount of change. All right, so let's go to our calculator. And what I want to do is I'm going to reset my calculator. And I'm going to put in my new Y1s and Y2s. So I'm going to be careful, I'm making the second one my Y1 because that's my input rate. So this will be 15 x divided by 1 plus 3x. So 1 plus 3x. All right, and then y2 is going to be 2 plus 5 sine 4 second pi x divided by 25. Okay, so there's my y2. Then I'm going to do part A, which is math 9 from 0 to 6. Okay, R is my y2, so I'm going to put y2 right in there. And I get 31.815 if I truncate, 31.816 if I round correctly. And do I need to talk about the units? I do. So if I integrate a rate, I get an amount of change. So if this is cubic yards per hour, and I multiply by hour, I'm going to get cubic yards. It's the amount of sand. Okay? All right, write an expression for yt, the total number of cubic yards of sand on the beach at time t. This was just like the at that I wrote before, okay? And I'm just going to call it y instead. And remember, if you integrate this rate, you get the amount going in, then you add that with the amount existing, and then you subtract the amount going out. I just like to put the 2,500 first so that there's no question about what we're actually integrating, okay? You're not going to integrate the 2,500. If I put the 2,500 last, like if I put the integral of st plus 2,500, this becomes ambiguous. Am I integrating just the st, or am I integrating the st plus 2,500? And so that's why I like to put the 2,500 first, the initial amount first, plus the amount going in, minus the amount going out. Okay, let's get our limits here. This starts at time 0. It goes all the way up to time 6, but we don't know what time we are going to stop at, so let's stop at time t. And this will also be 0 to t. All right, the next question says, find the rate at which the total amount of sand on the beach is changing at time t equals 4. So basically it's saying you have a rate going in and you have a rate going out. What's the net rate? Okay, and the net rate does not depend on the amount of sand on the beach. Okay, just like remember I had amount of money going in and amount of money going out, spending money. The net rate did not depend on how much money I had in the bank. All right, so this really will just be y1. If I grab this picture, let me grab this picture here. It'll be y1 minus y2 at whatever time they're specifying. Okay, that's the net rate. So I'm going to do y1 minus y2 at time 4. So this will be really y1 at time 4 minus y2 at time 4. So I'm going to put this into my calculator. Alpha trace y1 open parentheses 4 minus alpha trace y2 open parentheses at 4, and I get negative 1.908 if I truncate, negative 1.909 if I round correctly. Does it ask me for units? No, it doesn't ask me for units, so I don't need to put units. But it is a rate, so if I were to put units, it would be cubic yards per hour. Okay, but again, don't put units unless they ask for it. So if I were to do part D on this problem, this says for time between t is 0 and 6, what time is the amount of sand on the beach a minimum, and what is the minimum value? Justify your answers. If they're asking for when the amount of sand is a minimum, that's an absolute minimum. So what you do for all of these problems is you do a candidates test. You put time on one side, and you put the formula for the amount of sand on the other side. And we know the formula for the amount of sand. It's yt equals 2,500 plus the amount going in, right, st, minus the amount going out. And the limits here would be from 0 to some time t up to 6, and 0 to t here. Since both of these integrals have the same limits, we could actually combine this to one integral, and that would just save us some time writing in the calculator. Okay, so you can change that to this. So I'm going to go ahead and replace that. All right, so that's the formula for the amount of sand. And inside the candidate's test, remember, you have endpoints. The endpoints for time here are 0 and 6. And you have critical points, or critical values. Critical values happen when you take the derivative of f and set it equal to 0, if this is x and this is f. But if this is y, then all I would do is I would take the derivative of y and set it equal to 0. But what is the derivative of y? Well, you just take the derivative of this expression here. The derivative of 2500 is 0, plus the derivative of an antiderivative. So that's going to be the derivative of t, which is 1, times plug in the t. So you end up just getting 1 times s of t minus r of t. Then you subtract the derivative of the bottom, which is 0, times s of 0 minus r of 0. But of course, this is all times 0, so you get 0. And so what you get for y of t is s of t minus r of t. You set that equal to 0, and so solve for t. And how do I know when s of t minus r of t is 0? Well, s of t, remember, is really y1. R of t is really y2. So it's when y1 minus y2 is 0. And so what you do is you set these equal and you solve for t, or you solve for the x where y1 intersects with y2. So if I go to my calculator, I have y1 and y2 here. All right, I can go ahead and graph this. Let me change my window. I had zoomed this in. So let me change my window. Oops, I want to go back. Okay. So where y1 and y2 intersect is going to be at this x and this x right here. And you just need the x's or the t values less than 6. So 1, 2, 3, 4, 5, 6. So probably these 2 points here. I'm going to go to zoom box, and I'm going to enlarge just this first quarter here so I can see where these 2 points are. I'll change my cursor to -1, -1 here. Pin that box down at the bottom corner there. Go up and over. Okay. I'm going to enlarge that quadrant right here to get these intersecting points. Here it looks like I may or may not have an intersection here, and then I definitely have an intersection here. So let me go to second, calc, intersect. Go to the left of my first point here, hit enter, go to the right of my first point, hit enter. When it says guess, hit enter. And it looks like there is not a point here. There's really only one intersecting point, and that x value is 5.1178, blah, blah, blah. And I'm going to call this number A. I can't round it yet because I'm still using that number, but that is my critical value. So I'll put A right in here, which is 5.1178. All right, so then what I do is I find all the y values on the right side. So if time is 0, I can see that this would be 2500 plus 0 to 0 of st minus rt. But if these limits are the same, what's the value of this integral? It'll be 0, right? So all that tells me is when time is 0, that the amount of sand is 2500. And we already knew that, right? When time is 0, the amount of sand is 2500. So that feels good that it matches our information. So then I need to know what's the amount of sand when time is 5.1178. Okay, so what I'm going to do is I'm going to stow this x value as A. So go to second quit to go to my home screen, okay? Then what I want to do is I want to type x stow alpha a, and what that does, that stores that value x as a. So anytime I type alpha a, I'll get that number back. And so then I'm going to punch this integral in 20, or this value for y in 2500 plus math 9 from 0 to, now this time is going to be a, so I'll hit alpha a up here. In here I'll put st, which is y1 minus y2. So the integrand is y1 minus y2 Don't forget to close off your integral with an X. Hit enter, and I get the value 2492.369. Remember you need to go 3 decimal places. I'll do the same thing. I can actually go up here, hit this integral, I think, and instead of a now though, I want 6 at this number. So I'll go back, hit 6 right there, hit enter, and this last number here for the last row, I'll have 2493.277. Okay, so all I need to do is choose the smallest y value. So the minimum amount of sand between times 0 and 6 is this number right here. And at what time does that occur? This time right here. So let me answer the question. The time that the minimum occurs is 5.118. I think it's, if I wanted the time, I think it might be hours. Yeah, it's hours. But it doesn't say to tell the units, so don't tell the units. And my minimum value would be 22,492.369 cubic yards of sand. All right, that's my answer. What's my justification? My justification is my candidate's test, and my candidate's test should be correct to at least 3 decimal places.